All right, so let's start off here on number 2. So this one, I want to check GCF first, but I see that this one has no GCF. There's no number or variable that these can both divide by, but I always want to check that first. But then I do see that these are perfect squares, so I can actually use my factoring perfect squares technique here whenever it's a binomial, and we have subtracting. It's really important that we have subtraction here, which we do. And so what we do is we kind of take the square root of each of these, so it's going to be n and 8 on both of them. The square root of 64 is 8, and then the square root of n squared is really just n. And then for the signs, I do 1 plus and 1 minus, and that's it. All right, once again here, I check number 4. I see that there's no GCF here. Again, there's no number that those can both divide by, but I do see that they are perfect squares, so I can just do the square roots here. So that would be 9 and 4, and then the v as well. I just take away the squared, and I just do 1 plus and 1 minus, and that's it. You can do those in the other order as well. You can do the minus first and then the plus. It really doesn't matter. All right, number 6 here, I see that these are not perfect squares, and so I think that there's a GCF. I think I should be able to pull a 3 out front, so let me see. 3 divided by 3 is obviously 1, but 75 divided by 3, I don't know off the top of my head, so let's do some long division here. That's going to be 25, so it'll be minus 25k squared. And then I'm just going to leave that 3 out front, but I notice that we have all perfect squares here. So the square root of 1 is just 1. The square root of 25 is 5. And then I have the square root of k squared is just k. And then I do 1 plus and 1 minus. And then that's it. So when you take that GCF out front, it just kind of stays out front throughout the rest of the problem while I take care of everything else. All right, next up here, number 8. So now I'm going to look for a GCF first. I don't think it can be 2 or 4 because this one's odd. So I think it can divide by 3. Let me just double check here. Yeah, it does, and it's 49. So I'm going to take a 3 out front, and so if I divide both of those by 3, it'll turn into 4x squared minus 49. And then I notice that we have perfect squares, so I'm going to break it down more. So I get 2x and 9, not 9, it's going to be 7. And then 2x and 7 again, and then 1 plus and 1 minus in either order. All right, next up, we're still factoring here, so I need to check GCF. But there's no GCF on this one. There's no number they can all divide by, and then that last one doesn't have a p, so I can't take that out. So this is just going to be an x, so I'm going to put a times c up top, which is 10. B on bottom, which is negative 7. So I need to think of two numbers that multiply to 10 and add to negative 7. Now, since I'm multiplying to a positive, they're going to be the same sign. So I'm thinking about adding them together. So 1 and 10 doesn't work, but 2 and 5 does. But I'd have to make them both negative. So on this one, we don't have a number out front here, so we don't need the box. And so I would just do p minus 2 and then p minus 5, and that's it. I'm done. All right, next up here, number 12. So first of all, again, check GCF, but I don't see one. There's no number those can all divide by. So I'll do my x again, and we'll do a times c up top, which is 30, and then b on bottom, which is negative 11. And so now I'll think of two numbers that multiply to 30 and add to negative 11. So I can do 1 and 30. That doesn't work. 2 and 15. No. 3 and 10. No. 5 and 6 will work if I make them both negative. Now on this one, because I have this out front, I do need the box, or I'll actually show you a different technique as well. We'll do two different techniques. It's one or the other. So one technique you can do is put 5x squared from there, and then 6 over here, and then put these guys here and here, and then do grouping. So it's just you take these two numbers, attach an x to them, and then do the grouping. On this, you can see that everything here is right here. These two combine to make the negative 11x. So if I did the grouping, I would group these two together and these two. I would take out 5x, giving me x minus 1, and then take out negative 6, leaving me x minus 1. So I would get 5x minus 6 times x minus 1. Now, the other way you can do this is using the box. So for the box, it's kind of the same idea. I put 5x squared and 6 here and here, and those come from the expression way up there. And then these guys go in the other two boxes with an x, so negative 5x and negative 6x. So you see either way, you have to attach an x to these guys. And so then you do GCFs going this way, which would be 5x. And then these two would be negative 6. And then GCFs going this way would just be x, and then minus 1. So you see we do end up with that same answer either technique. All right, next up here, once again, I see no GCF, nothing everything can divide by. So we'll just use our x with either the box or the grouping because we have that number out front. So we'll do a times c up top. So that's negative 16, and then b is 15. So I'm thinking that would be a positive 16 and a negative 1. Okay, so then if you're going to be using the box, you're going to put 4v squared here and negative 4 there. That comes from here and here. And then these other two are going to go in the other two boxes, but you got to attach the variable to them. Okay, and then we'll do GCFs going this way would be 4v. It looks like there's no GCF here, but really that's a 1. And then since the closest box is negative, you make that negative. And now GCFs going that way is just v, and then here is plus 4. So you get 4v minus 1, and then v plus 4. If you use the other grouping technique, that should work. I'll do that on the next problem, but you should get the same answer. All right, next up here, they're definitely giving us a hint for the GCF first. So I think that 2 is the biggest number I can take out front. So then I get 7n squared minus 22n plus 3. And so now we're just going to leave that 2 out front, and I'm really going to focus on the inside here. So I need an x here. I am going to need the box because I still have that 7 out front. But we're trying to multiply to 21 and add to negative 22. So that sounds like negative 21 and negative 1. I'll go ahead and do the grouping here. You could use the box instead, but I'll just show this example. So I'm going to put 7n squared over here, and then 3 over here. And then the middle two are going to come from right here. So minus 21n minus 1n. We always have to attach those ones to a variable, no matter what technique you use. And then I'll do the grouping here. So I'm going to take out a 7n, leaving me with n minus 3. And on this one, it looks like you can't take out anything, but I'm going to take out a negative 1, which makes it n minus 3, so they match up. So then I'm going to get 7n minus 1 and n minus 3. But I do need this 2 that I've kind of been ignoring. That's okay, but you have to put it back at the end. You can use the box as well after that x, and you should get the same answer. So just don't forget about that 2 that we took out front. All right, this one's asking us to factor, but it's really GCF only. The CF, this is a greatest common factor. So that's all we have to do. So we just think about what's the biggest thing that these can all divide by. So with all the numbers, I see it's a 3, and then the smallest exponent is just an x. And so this one we need a placeholder is 1. 12 minus 3, or sorry, divided by 3 is 4. And then for the x's, I think of it like we took 1 out. We had 3, and we took 1 out, so now we have 2. And then this one will be, I had 2 x's, took 1 out, so I just have 1. So that's your answer. They're probably not going to put that first power there, so I'll just write it like that. All right, this one we just need to use the, we have 4 terms, so we're going to do the grouping. So I see the first group, I can take out 3r squared, and that would leave me with 5r minus 4. The second group, I could take out a 5, but since the third term is negative, I want to take out a negative 5, and that's going to leave me 5r minus 4. So I did end up with the same thing in both. So I get 1 parentheses for the stuff outside, and then 1 parentheses for the stuff r inside. So 5r minus 4, and that's it, I'm done. All right, this one I need to simplify. It's 2 parentheses multiplying by each other. So I get 2, I always use the box for this to multiply. Okay, and then I got 6x to the third. I got 3x squared. I got 3x. I got negative 2x squared. I got negative x, and I got negative 1. So now I'll just combine the like terms here. So 6x to the third doesn't have 1. These two are going to combine. 3 minus 2 is just 1x squared. 3x minus 1x will be 2x, and then that negative 1 out back. All right, next up here, these ones are just subtracting. That's very important right there. So the key here is this is not multiplying because there's a plus or minus in between. And so that means that we're not going to use the box here. We're really just going to distribute and then combine like terms. So this is going to become negative 6p to the fourth and then positive 7p to the third. So when you distribute that negative, it switches the signs. And then I'm just going to rewrite this one like normal. And now we'll combine like terms. So I like to do this in order. So I got the fourth power. Negative 6 and positive 3 is going to make negative 3p to the fourth. And then the third power, I got positive 6 and positive 7 makes 13p to the third. And then the I'll do minus 8 in yellow, just goes out back.